Hello dear students. In this video, we are going to learn the user interface of ANSYS APDL. Now, ANSYS, as we already know, that it works on the method of finite element method, and APDL is one of its window where we can do our analysis of any physical problem and obtain its solution. APDL is ANSYS parametric design language, and it is also called as ANSYS classical ANSYS, and this is what its user interface looks like. So when you will open the ANSYS APDL, uh, there are two windows that get open, right? So one is this user interface window. Another window looks like something like this. This is called as mechanical APDL output window. Okay, and it also shows the version of the ANSYS that you are having. Currently I am working on ANSYS 16.2. The latest version as of now is ANSYS 2021, right? So in this output window you will be able to see uh, all the works that we will be doing on the user interface window. In fact, the code running behind whatever we are doing in the user interface window, that code will be visible in this output window. All right, let's get back to the user interface window of APDL. Okay, so here as you can see on the top there are menu bar. There's menu bar in which we have file, select, list, and so on. So in file menu, there are different options that we have. That is clear and start new job, or this is to clear all the work that we have done previously and start with a new file, that is with a fresh start. Change job name will help to change the file. For example, the file which I am working on right now, its name is resuming 27032015. Okay, so if I want to change its name, then I'll go and change job name and its name will be changed. Then change directory, change title. Change the directory. By default, where the all the work is being saved, if you want to change that folder, that is the directory, then we can use this option. Okay, then if we want to resume some previously done work, we can use resume job name.db. That is here your file's name will come, and .db is database file. Then at different points we have saved by different file name. So at when the project is longer and we have saved different it's we have saved at different stages, then we can resume from that stage also. Then save as, write db log file. This is database log file. So this database log file is of very small size, and this we can take to another system and run it over there also. Then there are other different options of importing uh, some uh, CAD model software in different formats. Then we can export our also work also. Then report also can be generated and so on, right? So this is under the file menu. Then we have select menu. So when we'll uh, prepare some entity over here, in that case will be this option will be further elaborated. Then list, we can get the list of all the files status, the key points which we have plotted in our model, lines, areas, and so on. And similarly, its plotting can also be done. We can obtain the list. Then we want to highlight some particular key points or lines or areas or volumes, then we can plot them by giving their number or selecting them. And these further things are will be you will be able to understand properly in further lectures. Also, we have some shortcut buttons. So this is for new analysis. This is to open some mechanical APDL file, then save the analysis, then pan, zoom, rotate. So if we want to do that, the shortcut button is over here. This is for image capture and so on. This is called as command prompt. So if you have used AutoCAD, then in AutoCAD also we have some command line over here. Similar is the command prompt. So if we know the shortcut keys for performing any operation, then we can use command prompt also. And this button will show the recent commands which we have used. Right now, I haven't used any command, therefore this is empty. Then this is raise hidden. If something gets hidden behind the screen and we cannot find it, then we can use this button. Then reset picking, while we are doing some operation, we have to pick some key points or nodes or elements, and by mistake we have selected some uh, different key points, then we can reset the picking. Okay, then we have this toolbar. Here we have this toolbar. It has few buttons such as save db, resume db, quit, and power graphics. So this toolbar can be customized also. Uh, if in case in while working on a project, we require some other buttons which we use very frequently, then those buttons can also be uh, put over here, right? So this toolbar can be further customized. On the left, you can see the main menu. In center, you will see this black screen, and in the right again there are some buttons. Okay, in the bottom there is always it gives us the hint that what the next thing is to be done. Okay, so here we will get, and over here whatever the current selection is, or the current material or real constant or coordinate system, etc., that will be displayed over here. This square, the this black space enclosed by this white square is our main working interface. Okay, whatever we'll do, it will be displayed over here. Then as you can see, this version of answers is written over here, 16.2, then date and time. All right, then we on the right side we have these buttons for viewing our object in different views. So this is for isometric view, oblique view, then front view, and respective. All the 6 views are available over here. Then after the views option, we have this zoom option, zoom in, zoom out, zoom previous, right? Then we have this panning option. If you want to move or pan the object, then we can directly use these buttons, pan left or right, up or down, and so on. Then we have we can rotate about 3 axes, about x, y, z, in positive x or negative x, and similar directions. Okay, then we have for dynamic model mode for switching the selection, the mouse button selection. Okay, now on the left, the main menu. This is where the entire thing, that is our analysis, the all the steps for doing any analysis are over here. So first is preferences. In preferences, uh, we can select any one or two or all the three simultaneously, depending upon the question. So in the further classes, I will be selecting this structural analysis for doing the structural work, right? We can also do some thermal related work also, and fluid uh, related problems can also be solved in here. Okay, so we will select structural and we'll go ahead. Then there are 3 steps which needs to be followed while solving any problem in answers. The first one is preprocessor, second step is solution, and third step is general post-proc or general post-processing. Okay, in preprocessor, we define the problem, that is, we prepare the model on which needs to be solved. Then we prepare the model, that is a 3D model or 2D model or 1D model, whatever is required. Then we apply the boundary conditions, generate the same scenario as in physical problem. Boundary conditions, boundary value problems, and boundary conditions are assigned. Then we assign the type of material. Having the material is defined with the help of its properties, like what are the elastic constants which are involved with the material. So we define the material with respect to that. We provide the constants related to it. Then we provide the cross section. Then we do the modeling. Okay, we apply the loads, apply the boundary conditions, and then the preprocessor step is done over there. After that, we solve. We run this step, that is the solution part. Will run the analysis, that is, it will do the meshing, and then it will apply the loads and use the boundary conditions and give the solution to us. Now, in order to view the solution, we have to go in the general post proc, and in this we can read the results. We can plot various types of graphs with which we will be able to interpret the result which the software has given to us. So this is the general uh, process for by the help of which we will be solving our uh, problems or doing the simulation of the physical problems in the software and try to get a result, and its result, the interpretation of the result is done with the help of the our knowledge of engineering and our work experience, right? Whether the result given by the software, whether it is correct or not, or whether it is optimized or not. Further, we can do the optimization in this also, depending on the variables of the problem. So this is it for this video. That is the user interface of mechanical APDL. Thank you.